The concentration of hydrogen ion in a 0.2 m solution of formic acid is 6.4 into 10 to the power minus 3 mole per liter. To this solution, sodium formate is added so as to adjust the concentration of sodium formate to 1 mole per liter. What will be the pH of the solution? The dissociation constant of formic acid is 2.4 into 10 to the power minus 4 and the degree of dissociation of sodium formate is 0.75. Given is the concentration in the question. Concentration of formic acid is given as equal to 0.2 m. Concentration of sodium formate is given as 1 mole per liter, that is 1 m. Value of acid dissociation constant for formic acid is given as 2.4 into 10 to the power minus 4 and degree of dissociation of sodium formate is given as 0.75. This is the degree of dissociation of sodium formate. So sodium formate dissociates to give formate ion and sodium ion. So if alpha is the degree of dissociation, then at equilibrium the various ions present and undissociated sodium formate present will be C. C represents the concentration of the sodium formate multiplied by 1 minus alpha, and this will be C alpha, this will be C alpha. Now in the question it is given that value of concentration is 1 m. Here it is given that value of concentration of sodium formate is 1 m. So putting the value of concentration equals to 1, this becomes 1 minus alpha, this is alpha, this is alpha. Now what is the value of alpha? What is the value of alpha given in the question? It is given as 0.75. So this becomes 1 minus 0.75, this is 0.75 and this is 0.75. So 1 minus 0.75 is 0.25. Now what is the formula of pH? pH is equal to pKa plus log salt, concentration of the salt divided by concentration of the acid. So pKa means log 1 by value of Ka, that is 2.4 into 10 to the power minus 4 plus log, what is the concentration of the salt? Concentration of the salt will be 0.75 divided by concentration of the acid. Concentration of the acid is 0.2. So pKa value will be equal to 3.62 plus log 0.75 divided by 0.2 is equal to 0.574. This is 0.574. Now adding the values, the value of pH will be 4.194, or this can also be written as 4.19. So pH of the solution is 4.19. This buffer solution, that is combination of formic acid and sodium formate, is acidic buffer. HCOOH is the weak acid and HCO minus ion is the conjugate base. So weak acid and conjugate base, or the salt of weak acid with a strong base. So this combination, that is weak acid and its conjugate base, forms acidic buffer. What happens on adding HCl? For example, any acid is added to the buffer solution, then this HCO minus ion will combine with the H plus ion of the acid to give HCOH and Cl minus ion. So this is how the pH is maintained. Whatever extra H plus ion is added will be removed from the solution. Here in the concentration of the salt, that is pH is equal to pKa plus log salt by acid, the concentration of the salt is actually the concentration of this conjugate base in the solution. Therefore, here the concentration of the salt is taken as 0.75.